Welcome everybody. In today's lesson we're going to discuss compare instructions and conditional jumps in the x64 Intel and AMD processors. So what are compare instructions? Well, when you want to ask this, you need to ask what if statements are. I'm sure a lot of you know what that is. So, you can say things like if x equals 50, for example, in languages like C. Well, in assembly, the compare instruction allows you to compare memory or registers with a given value, much like you would with an if statement. So for example, CMP RAX 50. Compare the RAX register with 50. If the RAX register is 50, that's what we're asking. Now what happens when we run that instruction? Well, the RAX register is compared, and if it's equal to 50, then the 0 flag bit is set. Now the 0 flag is a bit inside the R flags register. After running the compare instruction, if the RAX register is 50, then that bit is set. Likewise, if the value in the RAX register is below 50, then the carry flag is set. Okay? The carry flag is also in the R flags register. But it's not just set, the 0 flag is also set to 0 in such cases, if the value of RAX is below 50. Now, if the RAX register is above the value of 50, then the carry flag and the 0 flag are both set to 0. Now, these flags are important because we can use other instructions later on that will check these flags and perform certain actions. So the compare instructions is just responsible for setting those flags based on the compare operation, okay? So, what is the JE and JNE instructions? Well, JE means jump equal, JNE means jump not equal. Now, we use these with our compare instructions to make certain actions happen. So, for example, JE label name, it essentially means jump to the label named label name if the 0 flag is set. And there's also an alias instruction for this called the JZ instruction. So depending which assembler you use will depend which one you should use, but usually assemblers support both of them because they're essentially just an alias of the same instruction, right? Next you have the JNE label name. This means jump to the label if the 0 flag is not set. So you can see by using the compare instruction and the JE or JNE instructions, you can make certain actions happen. So for example, if you look to the right, here we have some C code, and it says if the RAX variable is equal to 50, then run the code inside, which is just a comment that says it is 50. And to the left, you have the equivalent assembly code for that same statement. So you can see we say compare the RAX register to 50, and if it's equal, then jump to the it is 50 label, and then that will jump to the it is 50 label. Else jump to continue, okay? Which skips over the it is 50 label. So I hope that makes sense, guys, okay? So the compare and jump equal, they don't work as one. They perform separate operations. The compare is responsible for setting the flags, and the JE instruction is responsible for checking the flag. And if the flag is set or not set, perform a certain action, okay? This is how these compare instructions and operation instructions come together. So let's talk about the JB and JA instructions. JB means jump below, JA means jump above. So JB label name, this means jump to the label if the carry flag is set, okay? JA label name means jump to the label if the carry flag and the 0 flag are not set, okay? So putting it all together in this particular case, we compare the RX register with 50, okay? If the RX register is below 50, then we jump to the below 50 label down here, okay? If it's above 50, then we jump to the above 50 label down here. Now, if it's neither of these, then the next instruction will be this one in the equal 50 label, because neither of these caused a jump, right? You can see the test that it does here. So JB instruction says if the CF is 1. JA says if the CF is 0 and the ZF is 0, right? And those flags, remember, they're set by the compare instruction, okay? So if you look to the right, this is the equivalent C program for that assembly. So that's essentially what we're doing, guys, okay? JB is the equivalent to this if statement here, where we check if RAX is below 50. JA is the equivalent to the else if, where RAX is checked if it's above 50. And we don't need an instruction for the else because there was no jump. There was no jump to take us away. So naturally, the next instruction will be the else statement, which is here, the equal 50. Okay? And then we just jump to continue here, which takes us down to this continue label. Okay? So I hope that makes sense, guys. This is how we're able to use compare instruction and in the conditional jump instructions to make our program execution change. So thanks so much for watching this lecture on compare instructions. If you wanted a follow-up or have any questions, please let me know and I will try to help. Thanks for watching this free YouTube video teaching you a topic on assembly language. If you really like this course, you can even learn kernel development in the description and put those assembly skills to practice. Check the video description where you'll get a link to the paid course at Dragon's App, and you'll learn how to build your very own 32-bit protected mode kernel that's multitasking all from scratch.